Coming up on the Get Lean, Eat Clean podcast.
We should see, when we shift from a moderate or high carbohydrate diet to a zero carb diet, we should see increases in glucagon, adrenaline, cortisol. We should, I would say, feel a stress effect from that. I think that that's the normal shift from glucose to fat oxidation and then gluconeogenesis and ketogenesis. Those are the normal hormonal regulators of that state. And so I think we should feel that difference. I don't know if it should necessarily feel good or if it would be a good idea to not have any effects there. And I think this is why a lot of people might want to use exogenous ketones to help shift that faster.
So I'm going to interject there. So the stress response, I actually agree with. Like when you go on a ketogenic diet, there's an elevation of cortisol, catecholamines, and glucagon. But I believe my view is that that's a beneficial thing that helps facilitate greater fat adaptation. And then those things, I mean, according to our data and most published data, is that these things just come back with a eucaloric diet, will just come back to normal. It's much like, if I get under the bar and squat 500 or whatever, that's a stress and it releases all sorts of crazy things, right? But from my context, it's the adaptation to that stress that is most important. And I think some people, definitely communicating with them, they absolutely fail to adapt to a ketogenic diet, and they do it and they're actually losing weight, but their triglycerides go up and their LDL goes up and their blood glucose does not go down. And for reasons I don't really know, maybe they have some SNPs. They're just not good fat oxidizers. Mm-hmm. And most importantly, they don't feel good. They have a lack of energy. But if you go on a ketogenic diet and you sustain it, the benchmark is if you have lots of energy, if you're on a ketogenic diet and you're burning fat and ketones instead of glucose primarily, and you feel great and all your metabolic markers are great, then it would be hard to argue that that's bioenergetically unfavorable if you have energy. So how could it be bioenergetically unfavorable if the person has tons of energy and all the biomarkers are good?
Hello, and welcome to the Get Lean, Eat Clean podcast. I'm Brian Grin, and I'm here to give you actionable tips to get your body back to what it once was 5, 10, even 15 years ago. Each week, I'll give you an in-depth interview with a health expert from around the world to cut through the fluff and get you long-term sustainable results. This week, I interviewed neuroscientist, keto researcher, and professor Dr. Dom D'Agostino, and health coach and researcher Jay Feldman. This was a friendly debate discussing a myriad of topics such as what is the preferred fuel source for the brain? Is the clinical keto diet healthy in the long term? Glucose oxidation versus fat oxidation, the importance of gut health, and which foods to remove that could be toxic to your health. This was a great friendly debate between Jay Feldman for the bioenergetics field, along with Dom D'Agostino, who's been a long-term proponent of the keto diet. And I've been trying to get this on the books for a while. So I'm really excited to send this out to you. It's longer than most of my other interviews and went about 2 hours. So definitely sit back and relax and enjoy. You can watch part of it one time, part of it the other time. Either way, there was a mini earthquake in the middle. So I hope you really enjoy this friendly debate. You got a sort of a low carb versus a high carb approach. And this is part one. So enjoy my friendly debate and interview with both Don and Jay, and have a great day. Thanks so much for listening. All right, welcome to the Get Lean, Eat Clean podcast. My name is Brian Grin, and I have two great guests on for a nice friendly debate, Jay Feldman and Dr. Dom D'Agostino. Welcome to the show.
Thank you.
Thanks for having me on again.
Yeah, we found out they both lived in Tampa for a while, so maybe they crossed each other's paths at one point. But here we go, and I'm glad to have you both on. We're going to talk about a bunch of discussion points that I've mentioned earlier to both of them, but I thought it would be good before we get into that. I have had Dom on before, but Dom, maybe you lead us off and just give us a little bit of background of yourself, and then Jay, you can follow up.
Sure. Well, I've always been interested in nutrition ever since I was in high school, I think. And for sports, for football and things like that, majored in nutrition and biology as an undergrad. And that led to a PhD in physiology and neuroscience at Rutgers University. And then I did my postdoc that was funded by the Department of Defense and Office of Navy Research. And it was that work that led me to the ketogenic diet, because most of what I study in the context of nutrition or dietary interventions is for seizure control or neuroprotection. And we also do some cancer research. And I moved to Tampa in 2006 as a postdoc and worked my way up to tenured professor. Now I teach neuropharmacology, physiology, neuroscience, and also teach nutrition to the medical students.
Mm.
And mostly, and I work in some of the ketogenic stuff. So I have an appreciation for conventional nutrition guidelines, but also an appreciation for a low carb approach under certain situations.
Awesome. And Jay?
Yeah, so starting off with a very similar path, very much interested in nutrition from a young age for a lot of fitness driven inspiration, and that then led to in school I was pre-med and wanted to go that route. And as I learned more at the time a lot about low carb fasting, things like that, got very involved with all of those, and felt like the conventional medical approach was not the route to go. And so I finished my studies in exercise physiology and neuroscience and went on to do some independent research where I spent a lot of time reading studies and writing papers or writing articles, and also health coaching. So I work with people one-on-one and have shifted my perspective from a more low carb intermittent fasting type approach to one that more or less includes the opposite, which I'm sure we'll be talking about today.
Sounds great. And I first learned about Jay through Brad Kearns. He was on the BRAD podcast, and Dom has been on a lot of different podcasts, and I've known about him for a while. And he was a current guest a while back. I don't know, maybe 6 months ago, give or take. So I thought it'd be great to have you both on, and perhaps we can start off right off the bat with touching on advantages of like low carb versus high carb. I think this is like a common debate that goes on in many different circles. Maybe Jay, why don't you start us off? And I know you mentioned you started off doing fasting and low carb and things like that, and sort of led you down another path with like the bioenergetic path. Maybe explain how that came about.
Sure. Yeah. So I had been, in that space for a while, several years, and did various iterations there, including ketogenic diets and cyclical ketogenic diets. And over time, personally, was not experiencing a lot of what I felt like were the health benefits that were promised. And so that led to a situation where I was open to considering other possibilities. And when I came across some information that had kind of opened my eyes to the idea that maybe carbohydrates weren't the devil that I had taken them in to be, I started to shift my approach, and it led to a lot of shifts in how I felt in terms of energy, performance at the gym, adaptation to what I was doing at the gym, as well as libido and on there, focus, things like that. And so, and that kind of shift came, as you mentioned, Brian, from exposure to what's called the bioenergetic view of health, which is the idea that the energy that's produced, within the mitochondria of every cell is the currency that drives health and function, and a lack of which drives degeneration. And so that shifted my perspective in terms of how I was viewing physiology, and led to, among other things, the inclusion of higher amounts of carbohydrates.
Excellent. Okay. And Dom, I know you've obviously been involved with like the keto diet and the applications regarding that. What are some of the applications that you have found beneficial for the keto diet?
Mm-hmm. Yeah. Well, the first application really is I've been involved in the world of epilepsy and chaired the American Epilepsy Society Special Interest Group in dietary therapies. So that has been kind of like the thing that got me going. But so there are various operational situations where that make you more susceptible to having a seizure. And I was funded to study something that was kind of esoteric, which is breathing high oxygen at a high partial pressure or a high barometric pressure, which is using a closed circuit rebreather as the Navy SEALs do, and they dive and they risk CNS oxygen toxicity, which limits their operational activities. And also, hyperbaric oxygen therapy has 14 different FDA approved applications. The limitation is seizures. So I started studying various model systems from mitochondria to cells to animal models, rats and mice, and then to humans, and then myself. I became a subject and lived underwater for a while in ketosis. So I've been studying it mostly from the context of preventing a seizure, but also in the context of rare neurological diseases that are pathophysiologically linked to impaired brain energy metabolism from, for example, a deficiency in the GLUT1 transporter at the blood-brain barrier, Alzheimer's disease, which is a project that we had like more than 10 years ago. And we can kind of talk about the bioenergetic effects of ketones in the brain. But my very early studies were actually measuring superoxide anion in hippocampal slices and in neurons, reactive oxygen species, with and without ketones. And I noticed that oxidative stress went down. And this was like a clue that the ketones were impacting energy levels in the brain, and that when the brain cells were deriving energy from ketones, they were producing less superoxide, which is a precursor to more reactive species. And then that got me, this is like 2009 now, got me very interested mechanistically in how ketones work. So I connected with many of the icons in the field. Some of them have left us. Dr. Richard Veach, he was trained by Hans Krebs. He developed some of the first ketone esters. George Cahill, who did the seminal work in fasting at Harvard. But then I went down, studying various genetic disorders, cancer, glycogen synthase disorders, and a variety of different things. We have like a potpourri of projects in the field, and now we actually do some human clinical trials on, for example, using continuous glucose monitoring. I got a CGM on me, and we have patient data that we're working with, and also studying athletes that are using high carb, low fat, and low carb, high fat. So, and just got some data from that now, and could probably mention a little bit, but
Yeah.
we're preparing the manuscript for a pretty good high impact journal. So, and kind of embargo, but I'll mention some of the insights from that study because I think it could apply to the conversation.
Excellent. And yeah, we'll definitely love to learn about that. And I guess the question is, what fuel does the brain prefer? And maybe Jay, what's your thoughts on that?
Yeah, so preference I think is relative. Obviously, when ketones are available, the brain's going to use up to maybe 60 to 70% ketones, and then the rest will be mostly glucose. So yeah, when ketones are available, I think those are going to be used more so than glucose. When ketones are not available, glucose will be used. One thing that largely cannot be used, except for in very tiny amounts, is fats. And I think that is an important thing to discuss at some point as far as the fat oxidation and potential issues there. Maybe it's worth mentioning now, I have much less of an issue with ketones themselves or using exogenous ketones as much as I do from the health standpoint, and I'm sure we'll discuss the context with the ketogenic diet itself and what is involved in getting to that point where we are producing those ketones endogenously.
And Dom,
Yeah.
what are your thoughts around that?
Yeah, I mean, under almost all circumstances, the brain is using glucose as the primary energy source. Only in the context of fasting would we transition, and it's not like glucose to ketones, like a lot of people talk about. It's a gradual transition as ketone levels get elevated in the blood. They freely cross the blood-brain barrier and are used as an alternative energy source, but only in the context of fairly extreme situations. So that would be, limited food availability, I guess, which was pretty common. Our ancestors limited carbohydrate availability, which maybe some could argue not depending if you're like the Hadza or pre or post agriculture, Japanese societies, a lot of carbohydrate based nutrition. Uh, but as we age, the capacity for our brains to use glucose decreases with time. And that's not the situation with ketones. And we can get into that. And for certain things that we study, like even traumatic brain injury, there's like inflammation that could decrease the activity of an enzyme, pyruvate dehydrogenase complex, for example, which is a hallmark characteristic of Alzheimer's too, and other age-related cognitive disorders. Things like we look at like the GLUT3 transporter, which tends to be internalized when you have amyloid pathology. So these things would impair brain energy metabolism and in ways where elevating ketones in the blood through the diet, through fasting, that's a little bit tricky, but time restricted feeding or supplement could have benefits in that. But from a broad context, yeah, glucose under certain situations, ketones, fats in the form of short chain fatty acids and MCTs do cross the blood-brain barrier, so they could be used as fuel. And lactate and small amounts of amino acids could also be used, but kind of like in that order, It's really glucose or ketones, and then in some situations, lactate when you're exercising may contribute to. Actually, my first interest in brain energy metabolism was using lactate and delivering lactate with alpha L polylactate in the context of hypoxia or ischemia. And these are some of the first experiments that I was interested in doing in a hippocampal brain slice preparation in my postdoc. And then something, I just got steered into ketones.
Got it. And so I guess one of the questions would be sustainability of like a low carb diet. And I think Jay has points, and I've read a lot of his blog and listened to his website, that these when you are in a state of low carb or fasting, you're releasing these stress hormones and you're running on glucagon and adrenaline and growth hormone and cortisol. Perhaps Jay, maybe explain a little bit about your thoughts regarding that.
Yeah, so as Dr. D'Agostino had mentioned, the situations where we're producing ketones involve either entirely, food restriction, if we were in, you could call fasting, or long-term would be starvation, or if we're fully deprived of glucose or any carbohydrate source. And so and I guess you could say also the kind of intermediate step there is a shift largely from glucose oxidation toward fat oxidation, and then you get the ketogenesis generally following that. And so that shift in that direction tends to happen anytime we enter stress. We start to shift toward largely fat oxidation. And as you were saying, Brian, that tends to be largely mediated by, among other things, hormones, so largely glucagon. And then depending on how intense the stress is, we end up with adrenaline or epinephrine, growth hormone, and cortisol. And so this immediate stress state relies largely on fat oxidation. And then again, if it's continued long enough, we'll end up with ketone production. Now, when we think of this, I guess you could say biologically or evolutionarily, one of the, thinking of it in that big picture, one of my concerns is that these are states of prolonged stress and lack of food availability. And with that tend to be states where our bodies would want to depress their metabolism. And so and we see those effects not only in terms of the bioenergetic effects of largely relying on fat oxidation for energy production, but also in the hormonal effects. So normally in that initial shift, you'll see largely glucagon, but also a large amount of epinephrine and cortisol involved there. But over time, you'll see less of the cortisol and epinephrine other than the acute instances, and largely more glucagon. But that shift and those hormones tend to do a few things that will suppress the metabolic rate. One of which is decreasing the conversion from the inactive to active thyroid hormone. So they'll decrease the conversion from T4 to T3, largely at the liver. And less so glucagon, but especially more so the catecholamines and cortisol will end up depressing various other kind of pro-metabolic hormones that stimulate the metabolic rate, including androgens, especially for men, so decreasing testosterone production. And then also, see parallel effects in women, largely from progesterone. And of course, when we think of this biologically, it would make sense that we don't want to be prioritizing reproductive function or a high metabolic rate when we're in a starvation state, when we're in chronic stress. Because if we did, we would be using a lot of fuel that we didn't have at the time and put ourselves in a compromised position where we would die sooner if we're in this intense stress, if we're under starvation. And so we can kind of break apart each of those pieces or talk through those differences in glucose versus fat oxidation and those, because that's really where the signaling starts. But either way, my kind of largest concern here is that that state is not one that's conducive to health. And so it's not one that we want to be replicating if we don't need to, if we're not actually starving.
Thanks, Jay. Dom, do you have anything to...
Yeah, I definitely I share similar opinions in some areas, but we have a lot of data. Well, maybe I'll start off by saying that in the world of epilepsy, and I have different books, like this book was one of the first books I got by the late John Freeman, who is Dr. Eric Kossoff's mentor. And I tend to agree with the information in the books on epilepsy is that the ketogenic diet is not natural and it's not a healthy diet to follow. So it says that, like, I think in the first, in the opening line, and that's how it's viewed in the world of ketogenic diet as a metabolic therapy. So when I started studying it, like in 2008, and I remember being on a podium, I think in 2009, and mentioning that I was going to ketogenic diet, I think the audience thought maybe I had seizure disorder or something, but I was doing it just much like, I was doing it because I was researching it, and I wanted to understand what a true, like, 4-to-1 ketogenic diet was. But I do agree with Jay in that a ketogenic diet is not natural. It's probably not optimal for health, especially long term. But I continue to follow it and just kind of like, like living underwater for 10 days, not natural, but I kind of like, I did it for research purposes, much as like, but I've transitioned away from a clinical ketogenic diet. And I kind of agree with my wife in that I believe in flexible dieting, in that eat what you love to eat the foods that you enjoy, unless it's causing a problem, right? And my wife eats Ben and Jerry's every night. And she's very good with, I'm not good with portion control. She takes out the pint and has a little bit and puts it back. And for me, you put a pint in front of me, I'm going to eat the whole pint. So, and she does very well on a carbohydrate based diet, a higher carb diet. And she can back it up with blood work. Like her insulin, I think, was 3.3. Hemoglobin A1C is like 4.2. If you compared it, a doctor would probably say her blood work is superior. So maybe, a high carb diet is working. So I believe that any diet, that the thing that should dictate the optimal diet for the person is anthropometric, body composition, probably first and foremost, and then a whole range of blood biomarkers that we're measuring in the lab. So where I disagree, I think, is that, and we have a lot of data we're sitting on now. Some of it we've published. Right now we're writing it up. We have athletes, and then we have non-diabetic people who just were part of our clinical trial, registered clinical trial, who did a ketogenic, very low carb intervention for 12 weeks. So I would say, I'm looking at the data now because I just got back. We're working with a statistician. A prolonged ketogenic diet, if you want to call 12 weeks prolonged, actually they had normal amylin. So with normal amylin, the amylin induced glucagon suppression was normal. So that may go against what Jay is talking about. We had normal insulin, C-peptide, glucagon was normal, GLP-1 was normal. There were trends that were actually, the glucagon was slightly lower from at the, so that was a little bit surprising. And then we also expected and hoped that insulin would drop, but we didn't see a statistically significant. We saw trends and decrease in insulin, but leptin dropped. So you would expect leptin to drop. Ghrelin increased, which we were hoping that ghrelin would decrease. That our hypothesis was that ketones and a carbohydrate restricted diet, higher in protein and fat, would decrease ghrelin. We did see a trend for increased PYY. So, and that was, may factor in with the appetite suppression. But I would disagree that, and my glucagon is normal, my insulin is normal, everything's normal. I measure my catecholamines and things like that. Everything's normal. And, if something was going to be out of normal, I've been on the diet for a long time. We do not see a decrease in glucagon. I think it's important to note that in diabetics, so diabetics have elevated glucose because the amylin is not there, and you have accelerated glycogenolysis and gluconeogenesis driven by glucagon in that context. But if you take non-diabetic people who just have a little bit of weight to lose, like their insulin drops a little bit, not statistically significant in our cohort of 35 patients, but I think if we had 100 patients, we'd see that significant. And the glucagon was pretty much normal. What I think happens though, the first couple weeks, so we have it at time 0, 6 weeks, and 12 weeks. And I do believe in that first 2 to 3 weeks, you're probably going to see an elevation of catecholamines and cortisol and glucagon, but we're not capturing that. And then so that basically leads into this idea that the body adjusts over time. And if it was a chronic stress, it would show up in all these hormones, and we're not seeing it. I met with someone this morning that is amenorrheic because of the ketogenic diet, and their weight has been stable. So, and in females that follow the ketogenic diet for management of epilepsy, they're 5 times more likely to be amenorrheic when they get to like adolescent age and past adolescence. So there's something going on there that we don't understand. And when I got asked this question in the past, I would say, well, yeah, well, the athletes that are doing it are these CrossFit females that they jump on a ketogenic diet, they are calorie restricting, and they're over exercising, and that's leading to this triad of effects that are inducing that. But I've come to believe now that that female hormones can be significantly impacted just from the actual clinical trial data in the world of epilepsy. The only studies where we actually have very good data for the ketogenic diet is these controlled clinical trials for epilepsy, and that would show an increase in kidney stones, an increase in triglycerides, and some people LDL. We can talk about that a little bit, and the amenorrhea. It's a very real phenomenon.
Jay, any thoughts regarding that?
Yeah, it's interesting to hear the data, right, and to see potentially not an increase in glucagon. That certainly isn't what I've seen from the vast majority of data regarding, and some of it likely on animal models, looking at low carb diets, which again, lots of potential issues within the diets and methods that are used. Maybe it wasn't fully ketogenic and whatnot, but largely I have seen. Generally, we see I've seen an increase in glucagon, tend to see an increase in reverse T3 again as a result of that. Both, and I want to say as well on ketogenic diets, I would have to, go back through. But and I think it's interesting as well that we do see at least an impact on female hormones, which I think the assumption would be we would see the same thing in males, and that would have to be mediated somehow. Of course, it could be all. Like maybe there's no hormonal regulation and it's just due specifically to fat oxidation leading to lack of ATP and that impairing testosterone production sort of thing. But or again, decrease in thyroid activity, reducing STAR activity, so reducing the cholesterol uptake to convert to steroids. But I would I don't know what other hormonal connection there might be or what other hormonal intermediate there might be other than glucagon to kind of mediate that process. But yeah, I don't know if you have any ideas there, but either way, it's interesting to hear that data that you're collecting now.
Yeah. Well, that's why we measured amylin, and I thought because amylin controls glucagon, but we directly measured glucagon and insulin and GIP-1 and ghrelin and all the different hormones. So I expected actually to see an increase in glucagon. there is data in humans to show that athletes, that elite level athletes, this could have been, I forget who was the author of it. I have it. We're going to reference it in the paper, but there's at least one study showing that athletes that have a high level of output in that exercise, like 4 to 6 hours a day or whatever, have like almost double the amount of glucagon. And of course that makes sense. So we were proposing that this was one of the things that would show up in our study. But in normal people who are sedentary, who just want to use the diet to drop their body weight, we did not have a eucaloric diet because we were looking to optimize metabolic biomarkers. And we're analyzing the CGM data now. So we're looking at all that data now. But yeah, the glucagon just doesn't really, it's kind of uninteresting. And I was really a little bit almost questioning the insulin. And we used two different labs to measure insulin. So we're going to compare, we used the blood spot carbs by ZRT labs. But I think we have, blood work too through Quest to look at the insulin and compare that to make sure, there's, both labs were correct. But I really do think, like, with the diet, when it comes to diet, the big thing, people are trying to lose weight, and I am a believer of the calories in, calories out. So in that way, I'm a little bit in the middle, from the perspective of a high carb approach or low carb approach. But I also believe that what we eat determines profoundly how much we eat, right? And I've also observed, and I just gave a talk to the med students about this and just showed diabetes management with the CGM, eucaloric, before and after, from a high carb to low carb. And the CGM data looks like two different things. I mean, you'd see wild postprandial excursions and then, trying to chase it with insulin and then dropping. I think what's most important is that someone who has type 2 diabetes, and dare I go out on the on the platform to talk about type 1 diabetes, you could go, if you Google Andrew Koenig, TEDx talk. He was my former PhD student. He studied cancer cachexia for his PhD, but he's a type 1 diabetic. And when he joined the lab, he was just transitioning to a low carb ketogenic approach for type 1 diabetes. And it had a remarkable effect, on his brain, on his productivity and everything. So he uses that approach, and he works very closely with the American Diabetes Association and all the major players in diabetes, and gave a TEDx talk on it, talking about, I guess, what would be called the Bernstein approach, which is basically carbohydrate restriction and carbohydrate management for type 1 diabetes. So I'll defer to his website and TEDx talk on that. He's really on top of that topic. But I was asked at the American Diabetes Association to give a talk on a high carb diet versus a low carb diet in type 1 diabetes, or diabetic patients that were athletes. And my kind of pitch was that any diet that could optimize your glycemic management was going to be optimal for exercise performance. Granted, that's in the context of diabetes, right? So, and also we know with type 2 diabetes that postprandial excursions and wild fluctuations in glucose are associated with a whole host of comorbidities. So the question that we're actually working on with my medical students, we're working on a scoping review because this topic is such a nascent area of research. Does wearing a continuous glucose monitor and actually decreasing your glycemic variability, does that have any beneficial effect on various outcomes? And we're, analyzing the data to look at all the different outcomes. And what's striking is that there's not really good data on non-diabetics with CGMs, but we are under the impression that there's probably going to be a signal there, but we might need about 5 more years of data in non-diabetics to show that preventing wild fluctuations in your glucose would lead to better performance metrics, and maybe a shift in biomarkers too. But the data is not there yet, so we can't really say that.
Yeah. So to kind of go back through a little bit with the glucagon piece again, knowing that there is gluconeogenesis and ketogenesis going on in a state where someone's on a ketogenic diet, glucagon normally is the driver for those. So yeah, I wonder what is driving those. Obviously, low insulin and elevated glucagon tend to be the driver. So I'd be curious to know that. The other thing I would point out, so you mentioned this, that in athletes, you especially see the elevated levels of these stress hormones. And I've certainly seen research suggesting that there's increased sympathetic activity without carbohydrates available. If someone's on a high fat, low carb diet versus if there are carbohydrates available, which I think is potentially something to point to as well. But I think the piece that to kind of circle back toward what you were saying at the end in regard to diabetes, we certainly agree that, or at least it sounds like we agree, that if somebody doesn't have good insulin sensitivity and is not, quote, managing glucose well or managing their blood glucose well, they're normally better off on a ketogenic diet than continuing to have that poorly managed blood glucose and insulin resistance. And so I do think that that's an area where a low carb diet helps a lot. I don't necessarily agree that it's the best way, but I think that it is effective in a state where somebody is insulin resistant and essentially not metabolizing glucose well. And I think that is something that you mentioned in terms of epilepsy as well, right? There's elevated lactate production, issues along the electron transport chain, excess oxidative stress with the glucose oxidation as it is. And so supplying ketones in place of that tends to lead to resolution of that issue. And so I think there are a couple areas where a low carb diet shows benefits. One being that it brings relief from inefficient glucose oxidation. Somebody is insulin resistant if they're not oxidizing glucose well. If they're in a type 2 diabetic state, then having ketones and fat is going to be better off. But my approach would be rather to improve to the extent that it can be, and maybe in certain cases it can't be. But I think in the vast majority of cases that are lifestyle induced, that inefficient glucose oxidation can be improved upon, and proper glucose oxidation can be restored to allow for proper insulin sensitivity. And so that would be where my focus would be. And I think there's, beyond just the ketones displacing glucose potentially, or the fat displacing glucose, I think there are some other mediating factors as well where a low carb ketogenic diet can really help to improve glucose oxidation, especially in terms of the gut effects. So reducing endotoxin production and exposure, or lipopolysaccharide. And that being something that is a major driver of insulin resistance and poor glucose oxidation. And I think a low carb diet is really great at relieving that. Again, I think there are multiple ways that we can do that. And I'd prefer personally not to go that low carb ketogenic route because of the potential stress effects. But I don't know if that helps maybe kind of encapsulate more of the direction that I'm coming from here.
I'm not aware. I mean, just there's one paper in athletes, but I don't, I would not put me in that category or the majority of people. I'm not aware of human data, like randomized controlled trial data, really to show that there's a stress response. And our data certainly does not show that. We do have data, fresh data that we're preparing for a publication on low carb, high fat versus high carb, low fat. It's a crossover design. So these are fairly elite level athletes. There was 10 of them. And I'm looking at the data now. The most striking thing that comes out about this data is that 30% of the high carb, low fat athletes, 30% of them had a baseline blood glucose over 100 milligrams per deciliter. So it was eucaloric. So we tightly controlled for the calories, same amount of calories in low carb, high fat versus high carb, low fat. And what was interesting is that the greatest glycemic change and peak fat oxidation state was actually in people who were high carb, low fat that switched over to low carb, high fat. And then their peak fat oxidation state was determined by the delta change in the glucose, meaning that they started at a high glucose and from high carb, low fat, and they switched to low carb, high fat. and their glucose went. They were athletes, metabolically fit, obviously, and they were pre-diabetic because they were following a high carb approach, and they were not gaining weight or decreasing weight, but they had a significant decrease in glucose, and they actually ended up being the highest rates of fat oxidation. And then we have all the data, and we have a massive amount of data for this, and hopefully it'll be published within a month or two. But what was very interesting from just a baseline perspective is that the low carb, high fat group this is a 31-day study. None of them, I'll restate, all of them had a baseline glucose that was under 100 milligrams per deciliter, whereas 30% or more of the 30% of the high carb group, they were elite level athletes. Their glucose, there were two distinct lines on their CGM. Now, whether that's important or not, so I think there's been a lot of chatter online about, if you eat rice and your glucose goes up and you have these spikes, is that a bad thing in a healthy person? I don't think it is, but what happens with me and what happens with other people too is that in about 2 hours you get the postprandial dip, and you get a mild signs of a little bit of hypoglycemia, and then you kind of get hungry again. So what I've experienced, and it doesn't have to be a ketogenic diet at all, it's just switching from maybe 60-70% carbs to 30% carbs, which is like moderate carb and high fiber, and that can pretty much abolish or attenuate significantly those spikes. And then you have very good carbohydrate management. So I think that's my opinion is that for the majority of athletes, that that the a very low carb approach probably is not optimal, but just carbohydrate management and being metabolically aware of your glucose. And because if you're basically just fueling your body from a high carb approach, you become metabolically inflexible. So the idea then is if you're an athlete, is to periodically go low carb, maybe do some intermittent fasting here and there. But I think from someone who's metabolically healthy, my approach would be to basically try to promote metabolic optimization by enhanced metabolic flexibility and being able to use fats and carbs. And I think the true test for metabolic flexibility is just not eating for 24 to 72 hours. And if you completely crash and have a hard time with that, you're probably not very metabolically flexible. Whereas if you seamlessly transition from burning glucose and carbs to burning fat and ketones, then that's probably a pretty good sign that you have good metabolic flexibility.
Yeah, so there's a handful of different points there. In terms of I agree that we would want to titrate carbohydrate intake to tolerance. I also think that we would want to adjust the factors that would allow for, quote, tolerance, or I would just say efficient utilization. And I think there's a handful of factors to consider. So one, of course, we don't want to see extreme spikes in blood glucose that would either be due to a very, very unbalanced meal in somebody who's not very insulin sensitive, or just a lack of insulin sensitivity to begin with, and then seeing that dip and crash following. So for maybe an average person, I think having a relatively balanced meal that includes carbohydrates, fats, and protein, which tends to slow digestion, as you mentioned, also typically including fiber, will tend to mitigate that sort of response. And I think in somebody who has very efficient glucose oxidation and good insulin sensitivity, having something that's more carb-based without as much fat and protein should be less of an issue and shouldn't cause as much of a spike. And if it did cause a spike, it would be coming down back toward baseline quickly because that glucose would be utilized effectively. In terms of metabolic flexibility or inflexibility, part of my objection there, for one, is that I think it's the oxidation of glucose that tends to be far more sensitive to environmental issues, stimuli, various toxin exposure, whether it's lipopolysaccharide or mercury or cadmium, whatever it is, that when we're exposed to those states, or if we look at any state that is characterized by a more extreme exposure there, whether it's fatty liver disease or type 2 diabetes, we tend to see the fatty acid oxidation, the lipid oxidation being highly upregulated. And that being induced by stress hormones. You mentioned elevated gluconeogenesis, of course, is elevated lipolysis as well. And those tending to drive a state of both increased lipid oxidation, but also lipid storage. And that's part of my, I guess, again, the issue that I take with the idea of metabolic flexibility, which I don't know how much this pertains exactly to fat loss and whatnot, but I would basically regard fat oxidation as the default state that we resort back to when we're under stress or when we can't oxidize glucose. And I think for the vast majority of people, the capacity to actually oxidize glucose efficiently is where the issue tends to be. And so when we should see, when we shift from a moderate or high carbohydrate diet to a zero carb diet, we should see increases in glucagon, adrenaline, cortisol. We should, I would say, feel a stress effect from that. I think that that's the normal shift from glucose to fat oxidation and then gluconeogenesis and ketogenesis. Those are the normal hormonal regulators of that state. And so I think we should feel that difference. I don't know if it should necessarily feel good or if it would be a good idea to not have any effects there. And I think this is why a lot of people might want to use exogenous ketones to help shift that faster. So
I'm going to interject there. So the stress response, I actually agree with. Like when you go on a ketogenic diet, there's an elevation of cortisol, catecholamines, and glucagon. But I believe my view is that that's a beneficial thing that helps facilitate greater fat adaptation. And then those things, I mean, according to our data and most published data, is that these things just come back with a eucaloric diet, will just come back to normal. It's much like, if I get under the bar and squat 500 or whatever, that's a stress and it releases all sorts of crazy things, right? But from my context, it's the adaptation to that stress that is most important. And I think some people, definitely communicating with them, they absolutely fail to adapt to a ketogenic diet, and they do it and they're actually losing weight, but their triglycerides go up and their LDL goes up and their blood glucose does not go down, and for reasons I don't really know. Maybe they have some SNPs. They're just not good fat oxidizers. And most importantly, they don't feel good. They have a lack of energy. But if you go on a ketogenic diet and you sustain it, the benchmark is if you have lots of energy, if you're on a ketogenic diet and you're burning fat and ketones instead of glucose primarily, and you feel great and all your metabolic markers are great, then it would be hard to argue that that's bioenergetically unfavorable if you have energy. So how could it be bioenergetically unfavorable if the person has tons of energy and all the biomarkers are good?
So to bring it back, because you brought up a lot of points that I do want to come back to, but in terms of just the metabolic flexibility and using a shift into ketosis as a test for that was kind of my resistance. Was we should, as you said, the increase in stress hormones is a normal part of that. People might talk about keto flu or whatever is involved in feeling negatively during the shift in. And I would say, if you feel negatively there, that's not a sign of metabolic inflexibility. That's what I was getting at. Now, if you're already on the ketogenic diet for, let's say, multiple weeks and you're having trouble adapting, then yes, maybe there are some potentially genetically induced issues with fat oxidation or something along those lines. But in terms of just coming back to the metabolic flexibility component, I was just taking a bit of an issue with that as being a good test. And rather, I would say, how well does someone do to a glucose challenge? Especially, if someone's on a low carb diet, of course, we know that that's not going to go too well. But I would say in general, insulin sensitivity or glucose oxidative capacity is normally more limiting. And so when it comes to metabolic flexibility, that's the issue I have. Is I think people tend to focus on, can you oxidize fat well? I think the number of people who can't oxidize fat well is very, very small. And I don't know what sort of mechanistic things might be going on there. As I know you said you don't either, except for maybe some SNPs. But I think there are a ton of things that will inhibit efficient glucose oxidation. And we see that with the tons of people with insulin resistance. And so when it comes to metabolic flexibility, that would be more of where I guess my test would be, is how well are you oxidizing glucose? Because I think that's more of the kind of challenge for the average person.
Yeah, and I think for athletes, if we're not talking about someone with a deficit, with athletes, so as I mentioned, so my approach, if you're metabolically healthy, is to optimize metabolic flexibility. And my definition of metabolic flexibility is to formulate your diet in a way that optimizes carbohydrate tolerance, and that optimizes fat tolerance and ketone production. So that could be, I think, my opinion is that would be a mixed diet that's a little bit lower in carbs and keeps your body kind of hungry for carbs, and that can actually upregulate the GLUT4 transporter. Keeping your body a little bit hungry for carbs will enhance insulin sensitivity and actually facilitate glucose disposal in the context of a glucose bolus. In the context of a ketogenic diet that's sustained, or a very low carbohydrate diet that's sustained, there's no doubt in my mind that pyruvate dehydrogenase complex becomes not only, and I've seen data on this, that the actual protein levels when you do PCR is lower, and the catalytic activity of that is also decreased over time. So, but it takes a relatively small amount of carbohydrates to get that PDH enzyme back up to normal. But for like a large male, that could be 200 grams of carbs a day, and for a sedentary person, it could be 50 to 75. So, eating 4, 5, 600 grams of carbs a day seems unnecessary. And from the data that I've seen, you see some pretty big fluctuations. So my opinion is to probably my opinion for the optimal diet would be to cut carbs way down and then titrate it to where you're optimizing carbohydrate tolerance. But yeah, there's no doubt that when you restrict carbohydrates and you maintain that, you become carbohydrate intolerant. And if you do a glucose challenge, you're going to see that. But that adaptation comes back pretty quick. So when you reintroduce carbs, probably it takes about 2 weeks. You could actually convert someone who's completely carbohydrate intolerant to carb tolerant. Like that metabolic machinery seems to upregulate pretty fast.
Yeah, and I don't think that's pathological, right? I don't think.
No.
Yeah, to be in that low
It
carb
may be
state.
beneficial. It may actually be beneficial. And I've talked about this, although I think the data I don't like to speak outside of the actual data, but and I think this conversation maybe came out of just talking with Lane Norton, and as he coached, like the first time he coaches people for like a bodybuilding show to get them in shape, it's so difficult. But when you do it over and over again, like each year, contest or whatever, is that it's almost like their body knows what to do. And when you activate all those different pathways for fat oxidation, and he does it in the context of a high carb diet. So he's actually bringing patients down, or athletes down to extremely low levels of body fat and keeping their carbohydrates as high as possible. And this is completely achievable if you kind of, just balance just through energy balance, right? And just decrease the total caloric. My opinion is that that would be a little more painful than restricting the carbs to the point where you're elevating ketones, and then the ketones kind of keep brain energy metabolism kind of in check. Because if most people are trying to lose weight, and if you do it on a carbohydrate based diet, you're going to have fluctuations in glucose, and you're definitely going to get lows in your glucose. I remember experiencing this eating like just rice, like fish and rice, and like 2 hours later and that was essentially abolished when I switched out the rice
Right.
and added some vegetables and added like extra virgin olive oil, and my blood glucose was much more stable and with the same amount of calories. So I think it's important to just carb moderation is important, and maintaining that flexibility. But I do, from your perspective, I think that there could be a danger in restricting carbohydrates for too long, and essentially making you carbohydrate intolerant to a glucose challenge. That's very obvious. I've seen that quite often.
Yeah, and I don't see any issue with being in a state where someone's relying on fat oxidation and then is not going to be glucose tolerant. I don't see the lack of glucose tolerance in that state as the problem. I think it's just a normal adaptive feature of relying on fat oxidation. And as you said, for example, downregulation of pyruvate dehydrogenase, which of course insulin is going to majorly stimulate as soon as someone gets carbs in,
Yep.
consistently and whatnot. So yeah, I don't see an issue with that per se, but I think it's somebody who is not physiological insulin resistant, and someone who is what's called pathological insulin resistance, but largely the same or very similar mechanisms, where they're able to only consume, let's say, 100 grams of carbs without seeing those major fluctuations, or without seeing some sort of negative effect. I think that is an issue that would, instead of just reducing carbohydrate to tolerance, I would want to actually sort out what is the driver of that lack of tolerance or that lack of oxidation, and work on sorting that out. And again, I'm not saying here to then go on a super low fat, high carb diet. I tend to prefer, let's say, 40 to 55% carbs and maybe 30 to 40% fat, 25 to 40% fat. For myself, it tends to be higher, I think, based on activity and muscle mass. I have a better fat sink. But I'm not talking super low fat here, but I think that I think that we are addressing a symptom or responding to a symptom as opposed to actually addressing the root cause, right? And so if we take the extreme example of type 2 diabetes, yes, low carb is going to result in much more stable blood sugar and great improvements in how they're feeling, and probably weight loss and whatnot through a handful of mechanisms. But I would say, yes, do that, reduce carbs to tolerance to whatever extent needs to happen, but let's actually fix the impaired glucose oxidation that has come about over years and years of degenerative processes and, as you said, aging, which I think is not just a byproduct of aging, but rather is the aging itself, is literally impairments in the process of mitochondrial respiration.
I think we're totally on the same page, and actually I can appreciate, understand, and actually agree with the perspective that if you are an athlete, and maybe most people listening to this are an athlete, but most of the people I work with or in our studies for a clinical trial are not, and most people are just generally are not athletes. But if we're dealing with an athletic population, I think it's best to almost coach them and train their metabolisms to be maximal glucose oxidizers. So to actually titrate the carbohydrates in, might be best to use that with a CGM and gradually adjust and gradually increase the carbohydrates over time to basically assess their maximum carbohydrate tolerance. And then that could be introduced during the actual event, right? But I do think that having periods where you are decreasing carbs and keeping it kind of low can kind of reset insulin sensitivity after a period of carbohydrate surplus over time. I think the issue comes in is that the majority of people, to get benefits, body composition alterations, and favorable changes in biomarkers that are most important, insulin, HSCRP, triglycerides, especially triglycerides, hemoglobin A1C, and glycemic variability as measured through CGM, that some degree of carbohydrate restriction, independent of calories on a eucaloric diet, will lead to slightly favorable changes in those things in body composition. And I think it's kind of small. And I think the main driver for favorable changes in body composition alterations and metabolic biomarkers, cardiometabolic biomarkers, is undoubtedly a caloric deficit, right? If you're taking subjects it is undoubtedly a caloric deficit. And my opinion, based on just doing clinical trials and actually doing mouse trials too. So a ketogenic diet is hypopalatable and fairly hypersatiating. So it becomes like kind of an easy way to produce a calorie deficit. And then you see all these benefits, and there's quite a lot of studies showing, hey, a ketogenic diet lowers blood glucose, it lowers insulin, they decrease fat. It's because you're just reducing calories. You're not eating as much because the food doesn't taste as good. So I think that the majority of benefits of the low carb diets and ketogenic diets are simply due to the ability of eating this macronutrient profile, the ability of this to produce an energy deficit through a mild state of caloric restriction. So we've seen this in mice, we've seen this in rats, and the human data, in many cases, that it's just humans are awful at recording the amount of calories that they eat. And some people say they could eat so much more calories on a ketogenic diet and still lose weight and have favorable changes in body composition. But I would argue against that. I would say that the weight loss and fat loss and changes in important metabolic biomarkers like insulin and glucose are due 90% due to just creating a calorie deficit. But one thing that's not really debatable is that the glycemic variability will reduce significantly with a low carb diet and a ketogenic diet. So the big question is that even important? So that's something that we're researching now.
And I'll just add one thing regarding that in the sense that, so I was, for my story, like I've been low carb for a while. And, after just, I like to experiment, right? Like self experimentation. And you talk about like certain genetic markers potentially having an impact. And I got a gene test and worked with someone, and he analyzed the fact that I was like a slow metabolizer of saturated fat. And so we actually are looking to eat leaner meats and actually up the carbs. But I always like to teach the fact that it's good to track what you're doing for a few weeks to see like, where am I at? Because like for a while I'm eating 2 meals a day, pretty low carb, and sometimes one meal a day, and just noticing that, yes, like you mentioned, you are full longer. Like I was not that hungry. I don't know if that's a good thing or a bad thing, but for some people it might help. But I think for a while there, I was probably restricting calories too much and maybe causing impact on hormonal health. And I think this is maybe to Jay's point a little bit, is that when people get into this mode for a while and they're restricting for so long and creating stress per se, that it might take a hit on hormonal health. And so I'm actually testing it the other way and seeing how I do on high eating more carbs. I will say, if you go low carb for a while, it's tough to bring in those carbs. It's like, what I will say is, if you're going to add starches, at least from my personal view, add them in at the end of the day. don't have a baked potato in the middle of the day or rice, because you'll probably be knocked out and feel it. So I've been adding in more like fruits and things like that in the beginning of the day and for my first meal. And those I find, and I wear a CGM, I don't have one on right now, those, the glycemic variability on those is minimal compared to, I remember one time I made a sweet potato, had it in the middle of the day, and I was like falling asleep.
Yeah.
And the CGM read, I looked and I was like, whoa, it went to like, I don't know, 150, and obviously eventually came back down. So
Oatmeal too will do that. Yeah.
and it's
So what
interesting because
I've
a lot of
found,
bodybuilders will start the day with oatmeal, which I don't really get
oh, I
that.
did for many years. Yeah. But lentils, something like lentils actually has a significant amount of carbohydrates, and I have like almost a flat line on lentils.
Mm.
It's very mild. If you are reintroducing carbs back in, I would actually take alpha lipoic acid. Lipoic acid is part of the pyruvate dehydrogenase complex, and uh, alpha lipoic acid comes as a racemic mixture of R and S, and I would recommend using the R enantiomer of alpha lipoic acid at about 400 milligrams with carbohydrate, and you'll probably see that significantly lower. Maybe berberine, something too, but alpha lipoic acid is a good way to fire up and get the PDH uh, functioning again. It's part of the PDH complex, actually. So that would be, and then choosing something like maybe just eating more veggies, but lentils are, for me at least, is a good way to introduce carbohydrates back in.
Jay, Jay,
So
any thoughts on that?
well, so I just missed that. I don't know if you saw my camera shaking. We just
Yeah.
had a small earthquake, so
Oh,
and I don't know if it's
Oh,
fully
wow.
done yet. So
I was wondering
sorry,
what
I
was
missed
going
most
on,
of
man.
that.
That's my first interview with an earthquake.
Same.
Yeah.
But I think
Yeah, it's
I think we're
scary.
okay.
Wow.
Yeah,
Okay.
sorry
Okay.
about that.
No,
So
no problem.
talking about different carb sources, right, and
Yeah.
their
Talking
effects
about,
on blood glucose.
yeah.
Yeah.
And
Yeah.
also, and
And
Jay, I'm curious to know your thoughts. I know, Dom, you bring up calories in, calories out, and Jay, I know you've had some podcasts on that, and I'm mixed on that. I think it's, isn't it almost, it's very difficult to tell like what is your calorie output per se, and how can you even know? I feel like there is a bit of a guessing game. So anyways, Jay, I'm curious your thoughts on that as well.
Yeah, yeah. So from the carb source side, I would agree that fruits, especially between the balance of glucose and fructose and also the fiber, that tends to lead to a smaller glycemic response, with the fructose having a suppressive effect there, having a mixed meal tending to be beneficial. Ideally, I think we would want to be in a state where having some potatoes or sweet potatoes doesn't completely zonk us out. But when you're transitioning from lower carb, it might take a while until someone's at that state and, have more glucose storage for glycogen capacity and things like that. But as far as calories in, calories out goes, or just the idea that low carb or ketogenic diet is beneficial because of reducing calorie intake. So I do think it is good for that, right? I know normally we would see those effects on ghrelin, and interestingly, in the data you were talking about, Dom, you weren't actually seeing that, at least in, again, what you had there. But normally, that's looked at as part of the reason for reduced appetite. But I would actually say that I think there are other reasons why a low carb or ketogenic diet is beneficial that would not be just because of reducing calories, or would be entirely independent of that. And I think that would come down more to effects on the gut and the gut bacteria, as well as I was saying before, relief from inefficient glucose oxidation if there's any sort or version of insulin resistance going on. And I think that those would actually be more powerful. And then the next point I would get to there is I think there are other ways that we can accomplish those things that don't require the same removal of carbohydrates. And so maybe that's something we could talk about. But Brian, to your point, as far as calories in, calories out being extremely difficult to measure, I would certainly agree with that. It gets, it's nearly impossible to accurately measure either. And I think what a lot of people default to is, well, if you're gaining weight, you must have been in a surplus. If you're losing weight, you must have been in a deficit, and you have to reverse engineer it like that, which is a problem from a definitional standpoint. But you could say that it works as far as regulating food intake, but it certainly is very difficult in practice, because every food that we eat, the timing of the foods, what we're doing throughout the day, sunlight exposure, sleep, whatever else, is all going to affect that calories outside. And on the calories inside, we have estimates of how many calories are in any particular food, but there's some interesting research showing that sometimes those estimates are off by as much as 25%. And there's one on almonds that was talking about that, and also how much the processing of foods affects it, whether it's cooking or just literally the processing from whole food to processed version, affecting the calories inside, or actually how many calories get absorbed. And we have the digestive side too, how much is being absorbed versus how much is being excreted through those other means. So I think it largely becomes so difficult or nearly impossible to actually measure accurately that you could use it as, you could use the calorie intake as a kind of general idea of how much food you're eating. And then you can use your shifts in weight or body composition as a reflection of whether you think you're eating too much or too little based on your current diet. But I think as far as it just being, here's the exact number in and exact number out, I would argue it's nearly impossible to measure accurately.
Yeah, you definitely need to collect poop. So we know this from doing mice and rat studies. When you feed them a ketogenic diet, it looks like they were actually eating like twice the amount of calories. And we're like, wow, that maybe the diet does, is a metabolic enhancement. But the poop was like white. So our ketogenic diet is pretty high in MCTs, and it's got, a mix of different things. But it was very clear that they were pooping out a lot of fat and a lot of calories. So same goes, for human studies, well-designed human studies, you have to look at this. For example, if you're eating like a bunch of raw almonds, a lot of those calories are going to go through you for sure. I know for me, at least, eat a lot of nuts, and then various fibers, are converted to short chain fatty acids too. And I do think the gut microbiome is super important and relevant here, but there's just not enough randomized controlled trial data for me to talk about that. I think probably one of the questions that I got asked most frequently is, what's the ketogenic diet doing to the microbiome? Do low carb diets have a favorable effect on the microbiome? All I can say is that I get quite a lot of emails every day, about 100 from different people, and I scan them just to kind of extract information. And and I get back to as many people as I can. But people who have ulcerative colitis, people who have Crohn's disease or IBS or any form, they seem to have a favorable response to a carbohydrate restricted diet, interestingly to carnivore diet, which I'm not, a super fan of, but nonetheless, I can't argue with the data, anecdotal that it is that they are getting a favorable response from eating zero carbohydrates and zero fiber. Although I do not think it's a longevity. I don't know of any centenarians that are carnivore. I don't know if you, but I was watching something last night on Netflix about I think it's the Japanese, and there was basically all they this one population is all they eat basically a rice based diet. So it's just basically a super high carb diet, and they were talking to this one lady. She was 120 years old, at least 120 years old, but there was no birth certificate when she was born in the 1800s, and all she's eaten all her life was rice. And a lot of this entire population of people, they're all over 100, and they were basically eating. And it made me think, man, I don't think there's any like carnivore centenarians out there. Maybe there is. I don't think it's probably not the optimal longevity diet.
And Jay, I've heard you talk about this. I'm curious. I wanted to ask you regarding ancestral eating, and you talk about like the bonobos and the amount of fruit that they would eat, like 60% of their diet, maybe you mentioned. And I'm just curious your thoughts around that.
Yeah, well, so as Dom was pointing to, there are quite a few cultures that we know of currently that are very high, eating very high carbohydrates, especially in those blue zones. And I don't think it's just coming down only to carb intake versus fat intake or anything like that. But I think we can at least safely say that high carb diets do not mean shortened longevity based on those things. And we have the Kitavans, there's the Okinawans, there's a couple of others, and and they also have really, really amazing glucose tolerance or performance on glucose tolerance tests. And so I think that's noteworthy that oftentimes the more that we're oxidizing carbohydrates, the more favorable our bodies shift toward being able to oxidize them. And similarly with fats, right? We were talking about that too. If you're on a no carb or low carb diet, you'll be oxidizing far more fat as a fuel.
Yeah, and I think that there's the AMY1 mutation that is quite high for amylase, and it doesn't make sense that if we have very robust high copy number of amylase, so the Hadza, the Japanese, kind of have very high copy number of this amylase, that it makes sense that we were sort of genetically designed. But some people, I think, lack that, or don't have as high copy number. So I think this is a fruitful area of research. And I don't study that, but I was, sat in on a couple talks about this, and that this amylase mutation is being looked at to assess carb tolerance. And maybe it comes up as part of your 23andMe when you put it into different platforms, your prescription,
I put my 23andMe in Rhonda Patrick's. She has like a free, sort of, I don't know, free thing on her website where you can sort of get an analysis. And so it's interesting what you can learn nowadays through the gene snips. Yeah, go ahead, Jay. Were you going to say something?
Yeah, well, and amylase, of course, is most relevant when it comes to starch intake. And I think sugar intake through the form of fruits and honey can also be a considerable carb source, and depending on the population is. And so you mentioned the bonobos, who throughout the year are getting between 60 and 100% of their diet from fruit. There is a lot of fiber in that fruit as well, so they are also getting a lot of short chain fatty acid production as a result of that fruit consumption, but still ends up being a very high carbohydrate diet and a high sugar diet. And yeah, this is a little bit of a tangent from, I guess, our kind of conversation, but when you look in throughout apes, the ones that rely more on fruit intake over leaves and more foliage and more fermentation, there tends to be an increase in intelligence. And I think there's a handful of mediating factors there, but I think there's a suggestion that we don't want to be relying on fermentation and as a major source of our calories or of our substrate, and instead would want to be relying on easily digested food sources like fruits and also meat and fats that are digested pretty easily.
Yeah. What about we talk about like optimal health. I think everyone has like a different terminology for what that is, and I think one of those is like thyroid health. I'm just curious because I know just researching over the last few weeks, I mean, you talk to different people, but you've seen some stuff that could keto or low carb cause this hypothyroidism. And I'm just curious to know your thoughts and Dom, if you've seen this in any of your work regarding long term, low carb, if that could cause a adverse effect on thyroid.
I've not seen it in myself. My T3 trends to be in the upper high range, and my T4 is normal, and my THS has been normal. So, if I would have seen something happen by now. But with females doing keto and with people using a ketogenic approach in the context of high level of exercise or in the context of a calorie deficit, I've seen low T3 and a decreased conversion T4 to T3 or so that seems to be quite common, but it tends to be sensitive to insulin because insulin, I think, does activate the conversion, that deiodinase enzyme, the T4 to T3. So I think there's something there, but it may be very individual and maybe very context dependent.
Yeah, Jay, thoughts on that?
Yeah, I would largely agree that if someone's in a context of elevated stress, they're certainly going to be more likely to see that impaired conversion if, along with the low carb or even without, right? Elevated stress, regardless of whether of carb intake, but then especially I would say in a low carb state, you will see the reduction in deiodinase enzyme activity, the reduced conversion from T4 to T3, the elevated reverse T3. I've certainly seen, had people come to me with those issues, and it tends also to correlate with a trending up cortisol as far as fasting cortisol, trending up fasting glucose, which of course is not always the case, but certainly something I've seen commonly, and I think happens quicker or to a greater extent when somebody's low carb but not ketogenic. If they're, for example, on a carnivore diet and relying heavily on gluconeogenesis without the ketogenesis, and still relying to a much larger extent on carb oxidation, but getting a lot of that from the protein that they're taking in, as opposed to shifting into actually a fully ketotic state.
And Jay, you talk about like impaired glucose metabolism. How can someone improve that? Like what steps? I know you talk about gut health. Is that and we haven't even touched on like the rise of vegetable oils, and I'm sure Jay, you have some words on that. But what are your what would you say to someone looking to improve glucose metabolism?
Yeah, so that's where I tend to focus the conversation
Right.
is on these things that can impair proper metabolic mitochondrial respiration, proper glucose oxidation, and when that's not happening, it tends to shift us toward fat oxidation. And there are a lot of things that will cause that. So, as far as looking at endogenously produced things, we have the generic stress hormones that we talked about already, how those cause that shift. But there are a lot of external factors that can create that state. So you mentioned gut health, and I would say that lipopolysaccharide, which is also known as endotoxin, is really effective at doing that. It inhibits the activity of complex 4 of the electron transport chain, as well as complex 1. Also tends to increase various inflammatory cytokines and nitric oxide, which then inhibits enzymes in the Krebs cycle, particularly aconitase, leading to a shift toward citrate buildup, which inhibits glucose oxidation and also leads more toward fat storage and fat oxidation. And so that would be a huge one. And this is, lipopolysaccharide is produced by gram-negative bacteria in the intestine, but there's a handful of other kind of toxic byproducts from different gut microbes that I think are majorly problematic. And we see this in a lot of chronic health disease states. So you see low-grade metabolic endotoxemia in insulin resistance, diabetes, fatty liver disease, and obesity. And of course, the severe version of endotoxemia is sepsis, which is a product of incredibly inhibited immune activity and infection that tends to lead to death. And so I think that's a huge source of problems in terms of our ability to oxidize glucose, and then also trend toward an inflammatory state and a stress state that I don't think are conducive to health. And you mentioned the polyunsaturated fats. I would say those are another one. So, we can look at the omega-6s there and the omega-3s as well. I think there's a couple of stepwise places that we would see those inhibiting efficient respiration one of those just being I would say one of the biggest ones is actually their incorporation as phospholipids in the inner mitochondrial membrane, where they actually have a porous activity that actually create permeability there that inhibits or actually allows for protons to move through the phospholipid bilayer as opposed to being properly kind of separated in order to allow for proper electron transport chain function. And so through that means alone, they're going to reduce the efficiency of respiration. But then you also have the situation where when they are incorporated as membranes, or when you just have them kind of floating around, they're very susceptible to peroxidation, way more so than a monounsaturated or saturated fat. So as an example, if you look at DHA, which is the product of it's an omega-3 fatty acid, it's 320 times more susceptible to peroxidation than monounsaturated fat oleate. And you see arachidonic acid is about half as susceptible, so about 160 times as susceptible to peroxidation. And so those peroxidation products will have similar effects as well, where those are going to drive a state of uncoupling, a state of fat oxidation, where we're not efficiently able to oxidize glucose, where we're having trouble getting the ATP that we need without inducing kind of forced respiration through the catecholamines or through glucagon, which will cause calcium influx and cause a dramatic increase in the rate of respiration to produce ATP, but largely at a cost. And so those would, be a couple of things. I would say nutrient deficiencies would be another one as well. If we are low in thiamine, we're not going to be able to effectively oxidize glucose. We're going to have that inhibition of pyruvate dehydrogenase. And there's a handful of other nutrients, of course, that are involved too. So those would be just a few factors that I'd be looking to as far as why somebody might not be able to oxidize glucose efficiently.
Thanks for that. And Dom, anything else to share on that?
I actually, it's kind of my wheelhouse, studying PUFAs at the level of the membrane and membrane lipid peroxidation. So I used to measure malondialdehyde, and I actually developed the atomic force microscopy for biological applications to measure membrane lipid peroxidation as changes in membrane viscoelasticity and membrane roughness. You can look at the blebbing that happens with oxidized PUFAs. But I'm actually on the fence when it comes to like the seed oils and PUFAs in the diet, because the human randomized, controlled trials and things like that do not really support that these things are dangerous, or the data is still not. So as a scientist, I tend to just not so much comment. I do believe undoubtedly that when you heat these things up, they create a whole chain of oxidation, lipid peroxides. So this is actually part of the redox biochemistry course that I teach, looking at all the different lipid peroxides. And I've seen it in the lab. But when it comes to humans consuming off the shelf seed oils and things like that, I don't think the data is there to basically conclusively say, actually, the data goes in kind of the opposite direction. It's like more PUFAs is better than saturated fat, which is, I don't believe that either. But I don't think it's that much of a problem unless these things are heated up. And I think that's why, if you look at death rates and the health issues associated with fast food consumption, where they're using these things and cooking in them and heating them up, then I think a lot of the health consequences associated with fast food consumption is linked to these seed oils and PUFAs. But that's a bit of a stretch, so I'm a little bit reserved and hesitant to comment on. I've talked to Kate Shanahan, and we've had lots of long conversations about this and sharing publications back and forth. I do think she's onto something, but I just don't think the data's there yet.
And I would agree, as far as randomized controlled trials, that it isn't there. One of my objections there, one of the reasons I think we could say that, is because I found it to be very rare where there's actually a low enough PUFA intake to have an effect as far as depleting it, especially in the membrane. I know that it tends to be single digit percentages. I want to say under 5% until you're really seeing a shift there. And so I think that could be part of the reason. But I do think there's other relatively convincing evidence to suggest that they might be issues. And some of the great research that I would point to would be from Holbert. It's Jay Holbert, and he looks at the phospholipid composition of the mitochondrial membrane between different species and within species. And when there's higher peroxidizability, so higher amounts of unsaturated fats in there, it tends to be associated with aging and shorter lifespan. And so he's come up with the membrane pacemaker theory of aging, which is basically, I would say, kind of the next step beyond the reactive oxygen species theory of aging and the oxidative stress theory, which is kind of building on the old theory, which is the rate of living theory, and has shown that this can fully account for basically why certain animals that have a very high metabolic rate are actually not living as long. And when you control for phospholipid composition, the animals, including humans, that have the most saturated peroxidizability index of the phospholipids tend to age slower and live longer relative to the opposite. And he points to basically a handful of things. One is the susceptibility to peroxidation, and also an efficiency of respiration, where the animals that have much higher amounts of the polyunsaturated fats in those membranes are not able to produce energy as efficiently because of both the proton leak and also their permeability to protons, but also potentially to sodium and potassium as well. And that leading to a state where an animal is much less efficient at converting the fuel that it's taking in into energy. And so it has a quote higher metabolic rate, but it's really not because of elevated ATP, but rather because it's not as efficient with the capacity to produce energy from that substrate. And so that's a piece of evidence, obviously not the only one, but I think does point to this connection here between slowing aging and extending lifespan, and all of the diseases that come with aging being at least in part related to phospholipid composition and saturation index. And the kind of other piece there is when you look within a species where the saturation index is normally constant as opposed to between species, the higher metabolic rate tends to win out, and that tends to be a sign that, again, it's not a matter of metabolic rate, but rather actually a higher metabolic rate, which tends to correlate with lower reactive oxygen species production, tends to be the goal here as far as slowing aging and extending lifespan.
Mm-hmm. Yeah, I believe that. I don't think there's like a lot of evidence for these calorie restriction groups that slowing your metabolism, I think, will lead to ultimately a faster demise. I don't think it's going to prolong longevity, and I think it's probably going to impair your immune system over time. I know that the big study that was done in 2014 showed that actually a little bit higher blood pressure and a higher body weight, BMI, was actually associated with longevity if you can make it to 85 or 90 and having a relatively faster metabolism. I'm coming up on my next meeting I got to jump into, but but I wanted to, a couple things I just wanted to mention kind of clear about the ketogenic diet, that quickly say that, I'm a fan of the ketogenic diet in the context of a disease process, and I'm a fan of kind of flexible dieting in the context of kind of eat whatever you want as long as you manage carbohydrates. But I do want to make a statement that, because I think a lot of people talk about the ketogenic diet's a fad diet, that it's it's not a magical diet. And I would actually argue that it is kind of a magical diet, because the ketogenic, by changing your metabolic physiology, it fundamentally changes your brain energy metabolism, but most importantly, it fundamentally changes the neuropharmacology of your brain. And it also has an objective biomarker that you can measure it by. No other diet that we know of can actually fundamentally change the neuropharmacology of your brain. And it's not doing it through a calories in, calories out situation. So it has nothing to do with creating calorie deficit. So from that context, and that's kind of what I study, the neuroprotective anti-seizure. So I just kind of want to throw that out there, is that there's very legitimate use of this diet for epilepsy because it's altering the neuropharmacology of your brain. And I feel this has tremendous applications for neuropsychiatric disorders, specifically the field of metabolic psychiatry, which is something that I'm very passionate about. We didn't have time to talk about it now, but I just wanted to throw that out there, that it's a diet that is kind of magical in the way that it changes the neuropharmacology of your brain. And I think, my research is kind of going in that direction.
Yeah. No, thanks for sharing that, Dom. And
Yep.
And if Dom, if you have to jump off and you're up against it, we can.
I do. Yeah,
Yeah, that's
it's
fine.
a 90-minute cap, but I wanted to do 2 hours. But yeah, and
That's
I just
okay.
want to mention and plug, if you don't mind,
Yeah.
the Keto Nutrition website where we kind of hit the various ketonutrition.org. And also, I'm a co-host for the Metabolic Health Summit. So if you Google that, you'll come, and we're in the planning stages of that. But I, love this conversation between you, Brian, and Jay. I think it was great, and I think and it helps to basically bring it back into like a voice of reason when it comes to come to different camps. I think we agree probably on more things than we disagree on. So thought it was a great conversation, and look
Yeah.
forward to when it's out. And I'll put it into our newsletter, the Keto Nutrition newsletter, and share it around as much as possible.
Excellent. Well, Dom, we'll let you fly. Maybe Jay and I will finish up with some closing thoughts
Okay.
But I appreciate you coming back on the podcast. So
I'm glad to do a round two too, if you want to do that.
okay.
I just got to jump to a meeting.
Yeah,
Okay.
I'd be happy to do that. It was nice talking with you, Dom.
Great seeing you, Jay.
See
Great
you,
talking
Dom.
with you, Brian. Okay. Bye-bye.
Okay. We're good. All right, Jay. It's just me and you now.
Yeah.
Well, I guess there was a few other things that we could touch on, and then we can close it up for everyone, and maybe do a part 2 down the road with Dom. I guess let's come up with some actionable items for people. I think we talk a lot. We got very in the weeds, not in the weeds, but a lot of people probably don't understand 90% of the stuff that was going. So I think let's just bring it back to ground level, and perhaps just give some actionable steps for people, whether it's low carb, high carb, whatever. But what can people do to sort of, because I think one of the things that we should point out is doing any type of restrictive diet, keto, carnivore, a lot of the effects, that the positive effects that can come of it, is the removal of these maybe gut stressors, these highly refined foods, even the seed oil consumption is lowering those. So maybe those are the first items to discuss. But what some action items would you say, maybe if you had a client come in and instead of going like maybe the restrictive route, what route would you go?
Yeah. So I think you bring up a great point, which is where I think a lot of the benefit derives from in terms of the ketogenic diet. And I know we kind of mentioned this in our discussion with Dom, but I don't know if we ever really talked through it. I think he was saying on the gut side that he hadn't seen so much to suggest a clear impact, or at least as far as what is being impacted in terms of the entire effect on the gut bacteria and gut microbiome, which I agree it's not fully parsed out, but I think there are some particular benefits where you see the increases in Akkermansia bacteria, the Akkermansia muciniphila, and the parabacteroids. And just want to point this out because it'll circle back to part of my recommendation. I know we're kind of going into the weeds a little bit, but and there's evidence that just the effect of the ketogenic diet on the microbiome is one of the major things that leads to its beneficial impacts. And just transplanting the bacteria from mice that were on a ketogenic diet to mice that were not achieve the same benefit. And I think you tend to see the same thing with calorie restriction and fasting as well. And so I think that is one of the major reasons why removing a lot of the harmful foods, whether it's through a ketogenic diet or otherwise, can be really helpful, is through these effects on the gut and bringing relief to gut health that was not necessarily optimal. And my preference would be, instead of just removing all carbohydrates, removing any particular foods that you are either not digesting well or that are particularly hard to digest or contain a lot of the anti-nutrients, and instead including foods that are well digested, don't have those anti-nutrients. And I would say ideally that still contain carbs, and that way we could get that benefit, that one benefit at least of the ketogenic diet. I'm not saying it's the only thing necessarily. I think it's a huge one though. And also the translation of then a reduction in endotoxin and lipopolysaccharide being a big part of it. So what that would maybe look like for somebody who is just saying, all right, what do I do if I don't want to go full like restriction in terms of carbohydrates? Of course, restriction is a tricky word because I think we want to make different food choices, and some, we could perceive that as restriction, but at the very least, I don't think it needs to be restriction of calories or carbohydrates, which tends to be much more difficult. But rather what I would say is let's remove, I would say, the biggest offenders in terms of issues with the gut. And so I would look to raw vegetables, these raw leafy greens, especially, some of the fruit vegetables like bell peppers and cucumbers aren't actually, cucumbers would be,
removal of,
Well, so yeah, removal of the hard to digest ones. So like
Right.
raw leafy greens, I wouldn't have raw spinach, which is super high in oxalates, for example, or raw kale. I would remove raw nuts and seeds, or really nuts and seeds altogether, also because of their PUFA content. And the whole grains and generally the most processed grains as well. And shifting toward whole foods, shifting toward well-cooked vegetables, fruits, well-cooked roots and tubers, potatoes, sweet potatoes, squashes, things like that, which all tend to be digested much better. And I think that can lead to a huge improvement. And of course, an emphasis on animal products as well, good quality, low PUFA seafood and meats, I think, and saturated fats being particularly helpful too from that standpoint.
And do you have clients take a gut microbiome like test, like any type of gut test?
I typically don't have them take them, but I've had quite a few clients come to me who have already had them. I think sometimes they can be helpful. I think sometimes they give us the wrong idea. Sometimes it leads to a bit of an allopathic approach where we just see a reduction in a certain type of bacteria, so then we go and take a probiotic that has that bacteria, or we see extra amounts of certain harmful ones, and we take something to reduce those. And I think, for one, the microbiome is extremely complex, and we are only we only understand very small portions there.
Yeah.
And so I'm very hesitant to try to just replace the ones that are low and get rid of the ones that are too high, but rather would look to the things that tend to shape a healthy microbiome. And so for those things, I'd look to the polyphenols that are found in fruits and vegetables. Those tend to have selective antimicrobial effects, so they tend to selectively kill off or reduce the growth of what are typically harmful bacteria and support the growth of ones that are typically beneficial. Again, that's the polyphenols, and also some certain types of fibers in those fruits and vegetables that can be particularly helpful there. Having enough saturated fats to get good bile flow is super important for keeping our small intestine clear, so preventing SIBO. We're helping to get rid of SIBO. Having certain nutrients being very important for stomach acid production. So that's more of the lens I would look to, is creating a healthy microbiome from the food, as opposed to trying to artificially adjust an unhealthy microbiome that's only there as a product of our general state. Now, restoring a healthy microbiome isn't always as easy as just eating healthy foods, because if you're dealing with SIBO, let's say, and you eat something that has a lot of fiber, which wouldn't be an issue for someone who doesn't have that, or might not be, that could cause a lot of issues. You might be bloated and feeling particularly bad, brain fog and whatnot, and skin issues, and on from there. And so those are cases where we need to be very careful with our fiber intake and how we're adjusting the microbiome. We might need to use other tools, but those would be cases where you might have to lean away from the more fibrous foods and work on adjusting things more, particularly using supplementation or particular types of foods that might help more there.
And that could be sort of just like a self-experimentation of, you talk about like the ultimate elimination diet. I mean, a lot of times people say carnivore is like the ultimate elimination diet. And some people maybe need to go that route to heal first, perhaps, and then they can reintroduce other foods. Would you? Yeah.
Sometimes I would say maybe it doesn't have to go quite as far as carnivore. So
Right.
even if you have some really bad gut issues, normally you'll be okay with some sugar sources, some carbohydrate sources, sometimes honey or maple syrup. Sometimes those can cause issues, but sometimes they're okay. Sometimes really ripe fruits that are not too fibrous, sometimes some fruit juice. So those might be ways to incorporate some carbohydrate sources that are still not going to aggravate a gut issue. And part of the reason why I think that's important is because having a high metabolic rate and the reflecting elevated T3 or a good thyroid state and not being in a hypothyroid state is really important for restoring healthy digestion, for good bile flow, for good stomach acid production, and for good motility. And if we don't have that good motility, that'll lead to overgrowth as well. So that would be my hesitation with just throwing out all carbohydrates, is I would argue that that's going to lead us toward that sort of state, and that's going to potentially lead to compromised digestion. So I would not necessarily recommend going full carnivore, but you might need to really, quote, restrict what types of carbs you're eating at first while you're working on healing whatever issues there are gut-wise, and then you should be able to incorporate more carbohydrates.
Yeah, and I don't know if you're a fan. I know you're a fan of like raw dairy, raw milk. Is that right? Is that something you incorporate?
Yeah, I think dairy can be great. Of course, that's another example where
Right.
lactose intolerance is super common, but it's also not permanent. So lactose tolerance can shift dramatically based on our gut bacteria, based on our thyroid function and enzyme activity. So T3, being the active thyroid hormone, helps a lot with lactase production. Also, just not having anything with lactose for a long time will cause lactose intolerance, and you have to kind of titrate back and adjust back. So that can be a tricky one, but one that you can restore. You can restore your ability to consume dairy or to become lactose tolerant in the vast majority of cases. So yeah, I think dairy is a great one as far as a source of a lot of great vitamins and minerals, good saturated fats, some carbohydrates, and some good protein as well. But again, one that someone's going to have to evaluate individually as far as how well they tolerate it and how much they can have.
Okay. Well, to finish up, and then maybe we'll do another episode down the road. What maybe explain to me like your I know you and Mike have a podcast, Energy Balance podcast, and I definitely been listening to a lot of it. Just I like to be an open book and learn about different ways of eating, and I'm curious your routine, your eating, your workouts, and things like that, and how you manage it around your sort of bioenergetic point of view.
Sure. Where do you want me to start?
Well, for example, like how many meals? What do you typically? How do you typically structure those meals? And then perhaps workout and things like that. Workouts. I'm curious.
Yes.
Yeah.
I'll normally have three main meals, normally with a snack or two, or sometimes even three, depending on how the timing lines up and how big the meals are. And a lot of it is, I would say, not always optimal now just because of travel. And so my availability for particular foods and being able to work out, as we were talking about, I think before we went live,
Mhm.
is sometimes hampered by the sacrifices with travel. But normally I would say I would be eating maybe three square meals and then sometimes a snack between lunch and dinner if there's a longer spread there. Or if for whatever reason my lunch is pushed back, I might do a snack between breakfast and lunch. And then normally I'll have a snack before bed as well. And all of those meals tend to have a decent amount of carbohydrates and some protein and a decent amount of fat as well. And most of that will be.
And your carb sources are typically fruit.
Yeah, most of it will be centered around fruit, dried fruit, fresh fruit, fruit juice. I'll do some starch as well. So potatoes, I like potato chips cooked in olive oil or coconut oil. I'll also do some corn tortillas with nixtamalized corn. So that's corn that's traditionally processed in a way that deactivates a lot of the anti-nutrients and improves nutrient availability. And that's the traditional way that's done through Latin America. And so it's really easy to find corn tortillas that are nixtamalized. And so I'll do some starches like that throughout the day. And then normally with dinner, I'll have some form of root vegetables, whether it's sweet potatoes, sometimes white rice, things like that. So that's the main carb sources.
Mm-hmm.
For the most part.
Okay. And is there anything else you wanted to add? I mean, perhaps we'll do another one and talk a little bit more about the bioenergetic lens and how you guys go about it, because it obviously is a little bit different. And we've seen this shift to, like, obviously that's why I wanted to get you on and Dom on, is this shift to low carb. And I've always been a proponent of fasting. I mean, I know that you talk about how fasting obviously can put you in this stressful state, but the one thing I will say, and we can talk about this maybe on another time, but is that I like about fasting, it sort of gives you a boundary throughout the day, even if it's not like you're fasting half the day, but okay, I'm going to stop eating at 8 o'clock, because I don't want to be digesting food and going to sleep at the same time, sort of thing. And I think fasting can be used from that standpoint, where it gives you sort of these boundaries throughout the day. And maybe we can talk on that on another time. But go ahead. Yeah.
Yeah, I guess the question is, what's the purpose of those boundaries? Is it to prevent overeating? Is it to prevent, as you said, eating too close to bed?
Yeah, I mean, because a lot of times what's happening when it gets later in the day, I feel like people sort of start eating worse foods, perhaps more processed foods, and nothing really that beneficial to their health. So it can put boundaries around that.
It can. I think one thing I've seen a lot, obviously this isn't always the case, but
Yeah.
one thing I've seen a lot with people who tend to really struggle with junk food or with processed foods, and they feel like once they start, they can't stop. It's a whole pint of ice cream, like Dom said, and I'm not saying this is his situation, but the when people are struggling with that state, I think a lot of times it comes down to undereating earlier in the day and probably not getting enough carbohydrates in. And there are, in terms of hunger regulation, there's a ton of different signals. One of the major ones, I would say the kind of most, the one that's most deeply, that we're most deeply attuned to, that is going to be prioritized over any other, is the energy levels, the ATP levels in our liver and in our hypothalamus. And so if we're not supplying those areas with, assuming we're eating carbohydrates with enough carbohydrates, there's going to be constant hunger signals. And if we're also eating polyunsaturated fats and whatever else, it doesn't matter if we keep eating, because if we're not efficiently converting that to energy, we're going to be still stuck in that generalized low energy state that's causing this constant hunger. And so there's some great papers talking about overeating being the consequence of the state of inefficient respiration. So our hunger signals aren't actually turning off, and our bodies are giving us the right signal. They're saying we need more energy, but they're not efficiently converting the food that's coming into energy due to whether it is gut issues, PUFA, nutrient deficiencies, excessive stress for other reasons. And so that's where I would look. And so in people who I've worked with where they felt like they had to be really careful with certain junk foods or processed foods because they couldn't control themselves, or they tended to overeat them at night, when they just, I tend to suggest front loading in that case. And I don't actually mean putting all of your calories in the beginning of the day, but for most people, they're so low on food earlier in the day, and especially with carbohydrates, that if you just get in the idea more so of front loading, I really think it should be nearly even. But if you get into that idea, that mindset, and you start to eat some solid meals earlier in the day, a solid breakfast, solid lunch, and getting enough carbs in, the responses that I've heard from people are just astounding. Like, they're so surprised that before, when they couldn't have junk food in the house, because again, if they had a bite of the ice cream, the whole tub was gone and more. Mm-hmm. And now they'll eat a third of it or eat a bit of it and put it back. And it just completely changes that relationship with food. But again, I think this is coming from a place of actually fueling ourselves efficiently and not putting ourselves in a stress state where our bodies are starving for fuel intake.
Yeah. And no, that's a good point. And I'll just say, like, from my standpoint, and when I was talking to Brad Kearns about, we did an episode just not that long ago, and it just came out on his podcast and on mine, is I took a DEXA, I did blood work, and what else did I do? Oh, the gene snip, all this stuff. And I was like, okay, I'm going to shift a little bit more into like the bioenergenic lens and implement, now I used to never have anything in the morning. Now I'm having like fruit in the morning. And so it's definitely been an adjustment. I am going to the bathroom more. That could be
hopefully not too much, but I know that.
Yeah, go ahead. Yeah.
Well, I know like slow motility and constipation is super common in people not, on carnivore or not eating a lot of carbs, at least in people I've worked with.
Yeah. And now I'm going, and it's fine. There's definitely an adjustment, and I tried to sort of slow my way into adding in more carbs. And one thing I tell people is it is good to track, at least in the beginning, just to see where you're at. Because I think I realized I was probably undereating protein as well. And my carbs were obviously less than like 50, I'd say, on average, for a while. Now it's like I'll have carb counts of upwards of 200, which is fine. I think my body's starting to adjust. And so I'm sort of just doing the self-experimentation, and I'll go back in maybe 4 or 6 months and do a DEXA and do blood work and see how things play out.
Yeah, I'm curious to hear about it. I did listen to that episode, so you'll have to keep me posted. I love hearing those conversations and discussion of these ideas. And yeah, I would agree that we would want to ease in slowly tweak up the carb intake, both because of carb metabolism perspectives and also digestion's perspectives, and upregulating the enzymes that are going to help to break those things down, shifting the microbiome. I mean, I would say it's important to go slow. There's a lot of ways where it can go potentially sideways. And so, yeah, being careful and seeing how you respond and tweaking and adjusting.
Yeah. And so we'll see that. And I always tell people that that's a good place for everyone to sort of start, is like, maybe to get a DEXA or, take some measurements and just get a feel for where you're at. And then if you're going to make a change one way or the other, this way, at least you have a little bit of just evidence or something to sort of back up. But a lot of times it's how in the long run, how are you feeling? How are how are your workouts, and how's your sleep and things like that?
Yeah, definitely. And I know those were things that were dramatically different for me when I went from the lower carb fasting keto side of things to incorporating carbs. Like really night and day for me. And one of the night and day things too was the feeling of constant restriction, constantly looking at the clock as to when I could get my next meal in, feeling like I was just not, always having the carb cravings. And then also, as you were saying, how that translated to other things, how I was feeling throughout the day. And made a huge difference for me.
And we'll end on this and on this, but I am curious. I know, like, for example, I mentioned in the podcast that I have some genes that show that I don't metabolize saturated fat as well as maybe some other people. So it is interesting to see that maybe some people do better, obviously, on, like I just had a carnivore on. It's not published yet. And how he's been doing it and feels great and has good numbers, so it's, I don't know. It's sort of I think it's just an individual thing to some degree, perhaps.
Yeah, I think there's individuality. I think and this is normal, but I think the whole industry or the whole, everyone shifts one side or the other. So we went from saturated fat is evil to sugar is evil. So, lots of carbs, low fat to no carbs. And I think there is and not that I think that it's always the middle ground necessarily, or that like moderation is key. I'm not saying that, but I do think we swung too far on one side, and we took this notion that saturated fat led to elevated cholesterol, elevated LDL, and that no longer being the case. And that's just a symptom. And we don't blame the firemen for the fire. Yet then I think we've done the same thing with blood sugar and carb intake, and looking at insulin resistance and diabetes and saying, oh, elevated glucose, elevated insulin, those things must be causative in this state. We're really making the same mistake that we have criticized others for making as far as the cholesterol hypothesis goes. And so I think that's part of, it's something that's happening. But yeah, there's certainly individuality. I'm sure that some people are particularly better on one side or the other. And I think there's also, I don't think that we should ignore that, but I also don't think that doesn't mean that there's certain physiological principles that are truths throughout. And potentially we can change, maybe not for us, maybe for the next generation or on from there, how well we oxidize fats or carbs, or how tolerant we are to those things through various epigenetic changes, genetic changes, So I think, yes, there's individuality. I think there are also certain principles that are universal. And I think the idea is that we would want to shift not only us as individuals, but the entire human species toward better improved complexity and function, as opposed to the other way. And
you make an interesting point, and then we'll shut it down. But ancestrally, what was done has been looked at now a lot in a lens, and it's like, yes, there's some things that we can take from that, but is that optimal, right? Like, they were put in conditions that we're not in anymore. Right. So does that lead to optimal health? And I think that's
yeah. And I think that's absolutely an important line of questioning, right? Is semi-starvation occasionally helpful? Is occasional famine helpful? Is a lack of constantly available food helpful, right? I mean, we don't orient our whole lives toward what was happening then. We recognize that gyms are really helpful, and having a thermostat is helpful. And there's a lot of things that we do that are nowhere near what was naturally done then. I mean, when we look at even if we're on the low carb side and we're using MCT oil or olive oil from the other side of the world, I mean, yeah, I think there's a lot of questions to be had there. And yes, I think there's question as to how much carbohydrate there was available. I think that there is more than is often cited. Denise Midger has a great article about how ancient fruit is not free of sugar or super low in sugar and all fiber, like a lot of people point to. And so I think that we would have had fruit availability. And some people say, hey, if you're in Canada or northern latitude, how do you have had fruit? Well, if you look at the millions of years of our evolution, the vast majority was in largely tropical areas that would have had fruit nearly year round, if not year round. If we look at, as I was saying, mentioned the bonobos, if we look at where they currently live, which is, in a lot of the areas that we spent a lot of time throughout our evolution, they're eating almost all fruit. So I think carbohydrate availability probably would have been pretty decent, but I think it's even better now. And maybe that's an opportunity for us to be able to improve even further on what there already has been.
Awesome. Well, that was good place to end it. Jay, thanks for coming on. This was, the longest podcast I've done. So, and the first one with an earthquake. So
it was also the first with an earthquake for me, for sure. Yeah. Thank you for having me on. I want to thank Dom as well. And I'd be happy to further discussion, do a part 2, dig into any. I know we jumped around through a lot of different topics, and I don't know. Yeah, I don't know kind of how that went, but anyway, I'd be happy to jump in further. So
awesome. And best place to find you, Jay Feldman Wellness, right?
Yeah, so my website is jayfeldmanwellness.com, and my podcast is the Energy Balance Podcast. And for anyone who is, you were saying for someone who maybe isn't as interested in all the in-depth mechanisms, but wants to have some takeaways as far as what to do, as far as nutrition, how to adjust macronutrient intake, how do we adjust our exercise intake with the idea that we want to be increasing our cellular energy availability, the idea that increasing our metabolism is conducive toward improving our health. So yeah, if somebody is looking for some information there, I have a free 7-day mini course that goes through a lot of that information, a lot of those topics, and that can be found at jayfeldmanwellness.com/energy.
Perfect. And I'll put a link in the show notes for that. So, all right, Jay, thanks for coming on.
Yeah, Brian, thanks for having me.
Thanks for listening to the Get Lean, Eat Clean podcast. I understand there are millions of other podcasts out there, and you've chosen to listen to mine, and I appreciate that. Check out the show notes at briangrin.com for everything that was mentioned in this episode. Feel free to subscribe to the podcast and share it with a friend or family member that's looking to get their body back to what it once was. Thanks again, and have a great day.